What is science? Science is a way of understanding the world around us, a method that has evolved over centuries. It is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. Science is a way of understanding the world around us. It encompasses a wide range of disciplines, from the study of the smallest particles in physics to the vastness of space in astronomy. It helps us make sense of the natural phenomena we observe every day. It's not just about facts in textbooks. Science is dynamic and ever-changing, constantly updated with new discoveries and insights. The knowledge we gain from science is not static. It evolves as we learn more about the world. It's a process of asking questions and finding answers. Scientists formulate hypotheses, conduct experiments, and analyze data to draw conclusions. This methodical approach ensures that the knowledge we gain is reliable and accurate. Scientists observe, experiment, and test their ideas. They use a variety of tools and techniques to gather data and test their hypotheses. This rigorous process helps eliminate biases and errors, leading to more accurate results. They use evidence to support their conclusions. Evidence is the cornerstone of scientific inquiry. Without solid evidence, scientific theories and hypotheses cannot be validated. This reliance on evidence ensures that scientific knowledge is based on facts and not on assumptions. Think of a detective solving a mystery. Just like detectives, scientists gather clues and piece them together to form a coherent picture. They follow leads, test theories, and sometimes even go back to the drawing board when new evidence comes to light. Scientists are like detectives, but they investigate the mysteries of the universe. From the depths of the oceans to the far reaches of space, scientists explore the unknown, driven by curiosity and a desire to understand the world. They use their tools like telescopes and microscopes to gather clues. These tools allow them to observe phenomena that are beyond the reach of our senses, providing insights that would otherwise be impossible to obtain. Science is always evolving. New discoveries lead to new questions. Each discovery opens up new avenues of inquiry, leading to further research and exploration. This cycle of discovery and questioning is what drives scientific progress. This constant search for knowledge is what makes science so exciting. The thrill of uncovering new information and the potential to make groundbreaking discoveries keep scientists motivated and passionate about their work. It's a journey of discovery that never ends. Science is an ongoing quest to understand the universe, a journey filled with challenges and rewards. It is this relentless pursuit of knowledge that has led to the incredible advancements we see today, and will continue to drive progress in the future. The story of science begins with curiosity. Early humans looked at the stars and wondered about their place in the cosmos. They observed the cycles of nature and learned to predict the seasons. Ancient civilizations like the Greeks and Egyptians made important contributions. They developed mathematics, astronomy, and medicine. Thinkers like Pythagoras and Euclid laid the foundation for geometry. The ancient world was a time of great intellectual progress. However, much of scientific understanding was based on observation and philosophy. The idea of testing theories with experiments was not yet widespread. The scientific revolution, which began in the 16th century, marked a turning point in human history. It was a period of profound transformation in the way people understood the world around them. Before this era, much of the knowledge was based on religious and philosophical beliefs, often without empirical evidence. The revolution brought a new approach to learning, emphasizing observation, experimentation, and the questioning of traditional doctrines. Scientists like Nicolaus Copernicus and Galileo Galilei were at the forefront of this intellectual upheaval. They challenged long-held beliefs that had been accepted for centuries. Copernicus, for instance, dared to propose a heliocentric model of the universe which placed the sun, rather than the Earth, at the center. This was a radical departure from the geocentric model endorsed by the Church. Copernicus's heliocentric theory suggested that the Earth revolves around the sun, a concept that was revolutionary at the time. His ideas laid the groundwork for future astronomers and scientists to build upon. Galileo Galilei, using his improved telescope, made observations that supported Copernicus's heliocentric view. He observed moons orbiting Jupiter and the phases of Venus, providing concrete evidence that not all celestial bodies revolved around the Earth. His findings were met with resistance, but they were crucial in advancing scientific thought. Another towering figure of this era was Isaac Newton. Newton's contributions to science were monumental. He formulated the laws of motion and universal gravitation, which explained the movement of objects both on Earth and in the heavens. His work synthesized the discoveries of his predecessors and provided a comprehensive framework for understanding the physical world. Newton's laws of motion described how objects move in response to forces, while his law of universal gravitation explained the attractive force between masses. These principles not only revolutionized physics, but also had profound implications for astronomy, engineering, and other fields. His seminal work, Principia Mathematica, is considered one of the most important scientific books ever written. It laid the foundation for classical mechanics and influenced countless scientists and thinkers in the centuries that followed. The scientific revolution was a time of great upheaval and change. It replaced old ideas with new theories based on observation and experimentation. This period saw the birth of the scientific method, a systematic approach to inquiry that remains the cornerstone of scientific investigation today. The shift from a reliance on authority and tradition to a focus on empirical evidence and rational thought paved the way for modern science. It encouraged curiosity, skepticism, and a relentless pursuit of knowledge. This transformative period laid the groundwork for the technological and scientific advancements that define our world today. The legacy of the scientific revolution is evident in every aspect of modern life, from medicine to engineering, and continues to inspire future generations of scientists and innovators. The 18th century Enlightenment built upon the foundations laid during the scientific revolution. Thinkers like John Locke and Immanuel Kant emphasized reason and empirical evidence. This era celebrated intellectual inquiry and scientific progress. The 19th and 20th centuries witnessed an explosion of scientific discoveries. Charles Darwin's theory of evolution by natural selection transformed our understanding of life on Earth. Marie Curie's pioneering work on radioactivity opened up new fields in physics and medicine. Albert Einstein, perhaps the most famous scientist of the 20th century, developed the theory of relativity. His ideas revolutionized our understanding of gravity, space, and time. Science is not just something that happens in labs, it's all around us, shaping our daily lives in countless ways. From the smartphones we use to the medicine we take, science has made our lives healthier, easier, and more connected. Medical advancements have led to vaccines that prevent diseases and treatments that save lives. Agricultural science has increased food production, helping to feed a growing global population. Technology, driven by scientific innovation, has connected us in ways unimaginable just a few decades ago. The internet, smartphones, and social media have revolutionized communication and information sharing. The future of science is full of possibilities. In medicine, researchers are working on personalized therapies tailored to an individual's genetic makeup. Nanotechnology holds the promise of delivering drugs directly to disease cells, minimizing side effects. Stem cell research offers hope for treating diseases like Parkinson's and Alzheimer's. Scientists are also exploring gene editing techniques to correct genetic defects and potentially cure inherited diseases. The fight against infectious diseases continues. Scientists are developing new antibiotics to combat drug-resistant bacteria. Global collaboration is essential to prevent and control future pandemics. Artificial intelligence is rapidly advancing, with the potential to transform many aspects of our lives. AI systems are already being used in healthcare, finance, transportation, and entertainment. Self-driving cars, powered by AI, promise to make roads safer and more efficient. In healthcare, AI can assist doctors in diagnosing diseases and developing personalized treatment plans. However, AI also raises ethical concerns. As AI systems become more sophisticated, we must ensure they are used responsibly and for the benefit of humanity. Space exploration continues to capture our imaginations. We are sending probes to distant planets and moons, searching for signs of life beyond Earth. The James Webb Space Telescope is peering deep into the universe, revealing secrets about the early cosmos. Private companies are now playing a major role in space exploration. Space tourism is becoming a reality, offering a select few the opportunity to experience the awe of space travel. The future of space exploration may involve establishing a permanent human presence on Mars. Such an endeavor would require international collaboration and advancements in propulsion systems, life support technologies, and radiation shielding. Science is a journey of discovery that has been ongoing for centuries. From the early days of ancient civilizations where scholars and thinkers began to question the world around them, to the Renaissance period that sparked a revolution in scientific thought, the pursuit of knowledge has always been a fundamental aspect of human nature. It's a testament to human curiosity, ingenuity, and our desire to understand the universe and our place within it. This relentless quest has led us to explore the farthest reaches of space, delve into the deepest oceans, and unlock the mysteries of the human genome. Each discovery, no matter how small, adds to the vast tapestry of human knowledge. Science has brought about countless advancements, improving our lives in profound ways. From the development of life-saving medical treatments and vaccines to the creation of technologies that connect us across the globe, the impact of scientific progress is all around us. Innovations in renewable energy, artificial intelligence, and biotechnology are just a few examples of how science continues to shape our world. However, science is not without its challenges. The path of discovery is often fraught with obstacles, ethical dilemmas, and debates. Scientists must navigate the complexities of their research, balancing the pursuit of knowledge with the potential consequences of their findings. These challenges are a reminder that science is a dynamic and ever-evolving field. We face pressing global issues like climate change, biodiversity loss, and emerging diseases. These challenges threaten the very fabric of our existence and require urgent attention. The scientific community plays a crucial role in understanding these issues and developing strategies to mitigate their impact. It is through science that we can hope to find solutions to these challenges. By conducting rigorous research, developing innovative technologies, and collaborating across disciplines, scientists are working tirelessly to address the most pressing problems of our time. Their efforts are a beacon of hope in an increasingly complex world. The future depends on our continued investment in scientific research and education. By supporting scientific endeavors and fostering a culture of curiosity and critical thinking, we can ensure that future generations are equipped to tackle the challenges that lie ahead. The advancements we make today will pave the way for a brighter tomorrow. By nurturing scientific literacy and fostering a spirit of inquiry, we can inspire young minds to pursue careers in science and technology. Education is the cornerstone of progress, and by investing in the next generation, we are investing in the future of humanity. We can empower future generations to address the challenges ahead and create a brighter future for all. Together, through the power of science, we can build a world that is more informed, more innovative, and more resilient.